Namaste students, welcome to PAATHSHALA PANDIT. I am PAATHSHALA. Today we will learn about linear span. Okay, today we will learn about linear span. Till now we have learnt about vector subspace. Okay, vector subspace. And in that vector subspace we know that three rules are applicable to become a vector subspace. Before that we learned about vector space where 10 rules are applied. Now we will learn about linear span. So consider this, V means a vector space. Vector space has a few elements, few vectors. What are those? Consider them as alpha 1, alpha 2, alpha 3, and it goes on. Okay, it goes on. Now consider a subset. Okay, first of all, these alpha 1, alpha 2, alpha 3, they are satisfying those 10 conditions. Okay, now consider a subset. Okay, not a subspace, a subset of V, which we will name it as S. Okay, we will name it as S, and it has alpha 1, alpha 2, alpha 3 till alpha n. Okay, till alpha n. It is a subset of V. I am not saying it is a subspace, it is a subset. Okay. Now these vectors have been taken. Now consider some scalar quantities like k1, k2, k3, k4 till kn. The number of the number of vectors in the S is equals to the number of scalars here, and they are all scalars. Scalars means real numbers. In most cases it is real numbers. Okay, so if we combine these two things, then a linear combination is formed. How to combine them? K1 alpha 1 plus K2 alpha 2 plus K3 alpha 3. Like this, if we combine this with this, this with this, this with this, till it will go on till kn alpha n, then this thing will also give a result. This thing will also give a result which is also a vector. Okay, let it be vector b beta. Okay, let it be vector beta. Now the thing is, this thing is formed. This vector beta is also a part of this vector space. Okay, this vector beta is a part of this vector space. It happens like that. So let us name it as alpha only, because here everything is in alpha. So to avoid confusion, we are writing it as alpha only. Now since this is alpha and since a vector is formed, we will now see what is, this is now a linear combination. Okay, this is a linear combination because we combine these scalars and vectors. Linear combination. This is one linear combination. Okay, now see what is a linear span. Okay, this is a set S which is a subset of vector space. Now we will see a linear span. Linear span of S. Okay, always it is a linear span of something, so we are considering it as S. How it is denoted? It is denoted by LS, like this, LS. Here all it is first let me write it, K1 alpha 1 plus K2 alpha 2 till kn alpha n, where k1 k2 k3 till kn are real numbers. Means it is, linear span is a collection of all these linear combinations. For example, if I consider a particular set S which has only three vectors, alpha 1, alpha 2, alpha 3, let me consider it. So there will be one alpha, there will be one alpha, let it be alpha A, which will be like 1 alpha 1 plus 2 alpha 2 plus 3 alpha 3. Means here k1 is 1, k2 is 2, k3 is 3. Okay. Let us consider another possibility, because k1, k2, k3 they can be anything, they can be any real number. So let us consider another vector alpha b, and these are part of this vector space. Okay, because it is a linear combination and this is a part of vector space, these are also a part of vector space V. Let us consider alpha b as something else. How? Let k1 be something other than 1, like 2 alpha 1, plus let k2 be something else like 44 alpha 2, plus k3 be something else 36 alpha 3. Like this we are considering it something else, and like this many infinite possibilities come. Like now I can write alpha c is equals to 3 alpha 1 plus 2 alpha 2 plus alpha 1 alpha 3. Okay, we can consider it as like this also, 3 alpha 1 plus 2 alpha 2 plus 1 alpha 3. Like this many possibilities are possible, infinite possibilities are possible. Okay, so alpha, like this, the collection of all these possibilities is the linear span of S. It is the linear span of S. Okay, so like this the linear span is defined, infinite possibilities combined together. Okay, so understood. Vector space V, of that a subset comes, subset S. Using that and some of the scalars we can combine it to make a linear combination. The set of all the possible linear combinations is the linear span of S. Okay, these many possibilities can arrive, infinite possibilities can arrive. Set of all of that is the linear span of S. Okay, so yes, that's it for today. This was a short video on linear span. Thank you very much.